Hey guys, so another little setback here that I find pretty interesting that I'd like to share with everybody. So I use an 8-channel DSP that goes into this RCA magnetic decoupler. It's basically a transformer that outputs an RCA line that goes into the high voltage amplifier. The reason I do this is so there's no ground loop between the amplifier and the car. This does carry a 400 volt potential. If any of these any of the components in here would short circuit, we'd have 400 volts going to the car. I know that because I had a sound digital that shorted and that 400 volts went into the DSP and blew it up. So I want to avoid that again. So now here's the interesting part that I was not expecting. I took the car out and started doing some testing today, and something was off. One, it wasn't putting out enough power, and at a particular point when I would turn the volume level up, I would hear a weird, loud tuk tuk sort of noise, and I tried to figure out what that was caused by. So what we have here is the DSP puts out a signal that's 3.5 volts maximum. So it's about 3 volts RMS, give or take. Now, I was tracing that into the output of the RCA that goes into the amplifier here, and here's what I find very interesting. So I'm running a sine wave here, and what I'm going to do with my phone remotely is I'm going to increase the power on the DSP. That way the output signal increases in voltage. Now watch what happens as the magnetic field for the transformer collapses. So I'm going to slowly increase the voltage. So we're now at 600 millivolts max. Keep going up, keep going up. Bam! Once we reach about 1 volt, the entire magnetic field collapses, and now the transformer is just putting out junk. And this keeps going higher and higher voltage-wise until it matches the maximum of the DSP. So what I've done is I've had to limit the DSP power output on that channel, but it's a little bit more complicated than that. Even though I've done a sine sweep, so I'll show you what I mean by that. So I put it at this particular power level, and then I could sweep through the entire range and make sure it doesn't collapse. Even though that looks good, when I play music, because music is not a sine wave, right? You have all kinds of complex sort of different frequencies one on top of another. I get nothing but collapsing of the signal. So I have absolutely no choice for now until I get the new transformer ordered to run at a much lower power level into the amplifier. So here's a bass boosted song. It's boosted at 34 and 27 hertz, and we can see that in fact that is where it's peaking. So now I'll be running with the maximum of just 600 millivolts RMS, much lower than what it should be at 3.5 volts or 3 volts, so 400 millivolts. So right now I'm limited to 1/10 the power into the amplifier that will be amplified. So this setback means I have to wait days, potentially weeks, until the transformer I need arrives. I bought a Jensen transformer subwoofer transformer. It is 0.01% harmonic distortion at 20 hertz. The Blue Jeans one I'm using now is audiophile grade as well. However, I didn't realize that it had a 1 volt peak. So it was a line level transformer, and the magnetic field collapsed at above 1 volt. The new one I'm getting is plus 18 dBV, so it should easily handle the 4 volts that I'll be sending 8 volts peak to peak here to the amplifier. So I wasn't expecting this. I just thought I'd throw the Oscilloscope on it and see what's going on here. And I'm glad I found it because this causes all kinds of issues and clipping. However, right now I'm in a position where I can't really continue testing the car and seeing how much power it will output.